Thank you for coming to our talk. We're going to be discussing the static resource handling features in SpringMVC 4.1. That's a brand new release from last week, and it's one of the major themes for the Spring Framework version 4.1. But before we get started, just a couple of words about us. I am a committer on the Spring Framework, focusing on SpringMVC and web development in general. Prior to that, I did a lot of consulting and training for Spring teams, and got lots of other experience before that with Java and web development. And this is Brian.
Hi, I'm Brian. I've been a Spring Framework committer as well for over a year now, and I'm also the maintainer of the Sagan application, the application that powers the Spring.io website. And I'm also an open source enthusiast, so good thing.
Okay, so we'll get right to it. This presentation, as I mentioned, is about the static resource handling features that are in Spring Framework 4.1. We're going to be talking about that and provide some context about the general subject, because it is kind of an important topic for web applications, and we'll provide guidance. We'll talk about the design choices and kind of the thinking process that we went through, where we arrived, and we're gonna do that also by showing you the experience that we've had with Sagan, the Spring.io website, and how that informed us about the choices and the decisions that we made. So hopefully this will be a useful presentation. We have some sample code as well. So what's the resource handling in the Spring Framework? Prior to this point, essentially, it's a simple mechanism for serving static resources. We're talking JavaScript files, CSS files, etc., from any Spring resource location. And a Spring resource, it's an abstraction, which is one of like the core types in the Spring Framework that basically represents something that sits somewhere, like a file, or could be something in JNDI, could be anywhere really. And essentially plugging that mechanism into SpringMVC so that if you have to serve resources, you really can pull them from just about any location. This extensible abstraction is there, and that's what it's being used for. And in addition to that, there's also basic cache header management, which gets applied according to best practices for caching. And that's something which has been there for some time, since Spring Framework 3.0. So a number of years, and it's easy to configure. It's built right into the MVC Java and XML namespace configuration. And just a little bit of background, actually, of where this even came to be, why we even thought of this feature, is that for a long time in servlet applications, we used a prefix-based mapping. So your servlet might be mapped to /my_app/star. And then everything has to be prefixed with that in the URL. And then at some point, we wanted clean URLs. So a prefix was no longer desirable. And essentially, at that point, the root servlet mapping, where you map your servlet to just / became kind of the norm and the more common case, because then you don't need that special prefix for your application. And once you do that, that's essentially the default servlet mapping. That means that you become the default servlet mapping, and you being your application represented by the dispatcher servlet. So once the dispatcher servlet is taking all requests, that means it's not just taking requests for your application to do stuff, but it's also taking over requests for JavaScript files, for HTML files, for CSS files, and so on. And at that point, this feature was actually quite necessary in order to start serving resources and also add some best practices around it. So that's a little bit about the background of resource handling today. Pretty straightforward. But a lot of questions remain. If you're going to build an application, a web application, you're going to work with client-side resources, you really need to think about how to optimize them. That's really crucial for performance. You need to do things like minify, uglify, concatenate files so they can be served more efficiently. You may need to do transpilation for things like SAS or less if you use those. Gzipping also resources. If you're using a CDN, then you may need to actually modify some URLs in order to make sure they get served by the CDN. You need to deal with effective HTTP caching. So for example, we'll talk about version URLs in a moment. And while doing all of this, you also want to make sure that you have a good development, a smooth experience, so that you can just hit F5 in a browser and it just reloads, and that you can debug the actual sources, etc. So that's a lot of questions that still remain to be resolved. And what we're talking about here is developing kind of a comprehensive strategy for dealing with all this, and then we'll see how that breaks down in the Spring Framework version 4.1. But basically that is a goal, explicit goal for the framework. That's basically what we set out to do from the start when we started thinking about this new release. And this is just a comment here from a user in response to the blog post announcing the feature for the first time. It says, great to see the Spring Framework finally addressing this topic. There's clearly a lot of interest here. So how did it all start? Well, I wouldn't say this is what started it, but this is definitely an example of kind of an early indication of this coming. So basically, this is a request from a SpringMVC user, developer for fingerprinting URLs. And the description, if you were to go and look at that ticket, it's a fairly detailed description which basically says, well, this is what I've seen in the asset pipeline, which is a feature of Ruby on Rails. And one of its benefits is what it provides, what is known as fingerprinting URLs. And he wants to see that feature in SpringMVC, and he describes it in the context of the resource handling mechanism that we have. Just sort of try to project what would that look like inside SpringMVC. So that's kind of an early indication of what's to come. And as I mentioned in my yesterday's presentation, a lot of what happens in SpringMVC is very much driven from user requests and feedback, and this is no exception. So what is URL fingerprinting? It's kind of a term which is being ingrained, and if it means something to you, if you already know what it means, it makes total sense. But if you don't, then that definitely requires explanation. It's a technique essentially for effective HTTP caching, where we take the content of the file, we compute a hash from it, and we insert that as a version in the URL, and we serve that URL. So when we render the HTML, the link to the CSS file is going to have that version. And along with that, we're going to put some aggressive cache headers, future 1 year, which means that the browser is not going to ask for this resource again for a whole year. And that makes it very effective, because if you think about using something like if not modified since, that still requires a request to go to the server, and then the server can respond with a 304. And if you have 20, 30 of these on a page, which is not that unusual. I think there were some stats from Google. They did some research on what's the average page, how many hits per page. So these are not crazy numbers. And if you're on a mobile phone, 20 or 30 times going to the server is going to make a huge difference. So this kind of effective HTTP caching really makes a difference. And of course, when the file actually changes, then the version in the URL changes, and that busts the cache. And that's where the name of that feature comes from. Now, obviously, you're probably thinking, wow, computing from the content of the file while we're serving, this is computationally intensive feature. How is that going to help with performance? But we'll get to all that. This is just basically what the feature is about. Now, in addition to that, we kind of from a separate direction came to discussions for having a full asset pipeline proposal in SpringMVC. This is something that came actually through Rob Harrop, who is one of the founders of the Spring Framework, who basically came and said, well, you know, I've been using the asset pipeline with Ruby on Rails applications, and it seems to be really useful. This is something that we can probably do in SpringMVC as well. So we started thinking about it and talking about it. And after the first sort of rounds of the initial discussions, we quickly came to a major sort of realization that there's a fork in the road. And that fork is basically represented by building a full asset pipeline at runtime, which basically means that in addition to the fingerprinting URLs, also doing things like minification and concatenation, transpilation of SAS files, LESS files, to do all of that at runtime on demand as the requests are being made. We realize what needs to be done, kind of do the transformation, and then serve the files. So that's kind of the idea of the full asset pipeline. This is what Ruby on Rails does. And it's actually now in Grails. There's an asset pipeline there. Of course, there was the resources plugin before that. But now the asset pipeline is very much along the lines of the Ruby on Rails asset pipeline. Now, the other choice, the other fork in the road is represented by the possibility to use JavaScript build tasks, things like grunt or gulp. And those are build tasks which basically are used by JavaScript developers, and it's a very large ecosystem with lots of plugins, a big community behind it. Of course, it means using Node or having a Node installation for development purposes locally. You basically run these build tasks, they do all the optimizations for you, they produce some output files, concatenated, minified, and then you just serve that. So you can kind of see what the strategy around that might be. It's basically a build time approach where you optimize all your resources at build time as opposed to runtime. And the attraction of Grunt, using something like Grunt, is that, well, I mean, for once you have a very large community behind it, and over the long run, that means a lot. The velocity with which features are going to come, ideas are going to evolve, that is something that has a really big impact in the long run. And also, Grunt can be used with pretty much any backend, and I should also say with any front end as well. So maybe you're not even using JavaScript, maybe using some other approach on the client. That is an attraction for the build time approach. I'm going to turn over now to Brian, who's going to talk about yet another important development that came to be. Essentially, this is the Spring.io website. About a year or now 2 years ago, the Spring.io or the Spring Source website was essentially rewritten, and that was done with the help of Pivotal Labs. And for those of you who don't know Pivotal Labs, they're part of Pivotal now, but essentially they have deep Ruby on Rails knowledge for many, many years. They're very advanced, agile consulting company that basically teamed up with the Spring team, represented by Chris Beams, and they created from scratch the Spring.io website, which instantly became, first of all, an example of a production application, but also gave us a chance to collaborate with guys who are essentially, they're doing Ruby on Rails, and many of them haven't looked at Java for a long time. And to see their experience, and of course, Spring Boot was coming around exactly at the same time, and they were using it as Boot was moving towards a 1.0 release. And they were very impressed by the speed with which you can do development. Well, you've heard plenty about that in this conference already. And the website was launched at last year's Spring 1 keynote, which was brave, or some say suicidal, but it was successful. And as you can imagine, often what happens is that you have an idea, you're going to have this at Spring 1, and you rush towards it, and you create some technical debt in the process. And that's exactly what happened here, that there was some technical debt that needed to be paid off. And the idea was to open source from the beginning, to open source the website so that you can look at the source code and you can use it as an example and that you can contribute. So it is now in GitHub and it is open sourced, but before doing that, there was some work that needed to be done in order to make it a good example. And a major aspect of that was improving the client side. So you can imagine that Pivotal Labs, basically with their Ruby on Rails background, familiar with the asset pipeline approach that's in Ruby, they come to use Spring and Spring Boot, and they don't see the same equivalence. So that's kind of one side effect of using something like the asset pipeline. It shields you from knowing the client side to some degree, or how it gives you a strategy which makes it really easy, but then at the same time you're not as familiar with how you would do it without something like the asset pipeline. In other words, what JavaScript developers basically do. And this was done also with the help of John Han and Brian Cavalier, who you may know from the Cujo.js umbrella or set of projects. They're basically JavaScript developers. That's what they do day in, day out. That's where their minds are. And they are here. They'll be talking about Rave.js after this talk. So definitely take a look at that. And they were involved, and of course, Brian came along as well at the same time, and he got involved, and now he leads the effort. And it was an interesting collaboration, and he's going to talk about that now and tell you how they dealt with this whole resource handling issue, where the starting point, once again, is there's no asset pipeline. Here is something created by Ruby on Rails guys. Now, how do we take that and move forward?
Thanks. Okay, so when I came into the Sagan team to work on Sagan, so as Rossen mentioned, we were dealing with some technical debt we had accumulated before the official launch. So we wanted to have a client-side application that fitted with the rest of the application, because Sagan is a reference application. It's a production application. We want it to run smoothly, and we want it to be maintainable because we have to maintain it. But at the same time, it's a reference application, so we really wanted to have something that's clean, understandable, and state-of-the-art. So we sat there and discussed how we should deal with the current technical debt on the client side. So as Rossen mentioned, John and Brian are, their main focus is JavaScript, and they're really very knowledgeable about JavaScript and front-end development world. So when we sat there, the first thing they noticed was that the current situation wasn't really clear to them, and they were right, because in all Java applications nowadays, you often see that the JavaScript side, the client side, doesn't really fit in the Java world. I mean, the modern client side is often hidden, or it doesn't really belong. It's not a first-class citizen in Java projects, and you often see that. So when you see at the same time that those modern applications on the client side, now they have dependency management, they have their own Maven, if you say so. They have modules, they need tests, they need their dependencies, they have their own build. So when you see all that, that's what we have on the Java side. So why should they be hidden under SRC main web app? Why this layout, project layout, maybe is not the right way to do today? So it's common. That's everybody does that because that's the standard, and maybe that's the way many tools are working. But we thought that we weren't happy with the current situation, and so our first step was to reconsider that situation with John, Brian, and Chris.
So that's what you get when you put JavaScript guys on a Java project. You get honest feedback. Yeah, project slice into two and then start over. And so yeah, we totally rethought the project structure. So we, at first, all resources were under SRC main web app. And we heard that from the Pivotal guys that was some source of frustration while developing the website. So we thought, yeah, we must deal with it. So if you look at the Sagan project structure, the first column, you can see that there are 4 modules.
The Sagan site module is the main web app. That's the one we push to production, and that's the one you see when you hit spring.io in your browser. We have a Sagan common module, which is a common module with models and services and so here. And we have a Sagan indexer, which is another microservice that we deploy to PWS on Cloud Foundry. And that microservice is actually indexing the data from the main spring.io website and putting all those data into an Elasticsearch instance. So that's another microservice. And at the same time, we have now a sagan-client module. And that's the one we created. And we just thought, let's start with the situation we want to be in when developing Sagan, and then we'll deal with the problems later. So we started the sagan-client module, and we just gave total freedom to John and Brian, and they said what they wanted to see there. So they wanted to have their sources in an SRC folder, which is quite obvious from our side, but they didn't have that. So, so you want your sources, you want your metadata for your build, your dependencies, and you want some kind of target directory where your build, the output of your build lives. So that's where things actually live.
Yeah, and yesterday or a couple of days ago, he was talking about the ebb and flow that's in technical development that we encounter all the time. And this was definitely the case here, where we set out to build the client side, and we think that the challenge ahead is, how do you deal with resources, and do you use Grunt, or do you, do asset pipeline? And yet here we are, like, solving a very fundamental issue, like where should the resources live? But then once you get past that a little bit, you realize, wow, that's really a fundamental question. If you're going to talk about working with resources, what's the first question that you can ask? Well, where should these resources be in an ideal kind of scenario and situation? And as you'll see, it was a good detour. Basically, it was a necessary.
Totally. So our first step was to then create that Sagan client module, and we really wanted to follow the best practices and have the best tools available out there in the JavaScript world. We didn't want to have less than the best tools out there. So we started with the only requirement that we have, which is Node.js installed on your machine to build the client-side application. So you need Node, which ships with NPM, which is the Node package manager on your laptop. And then we decided on several technologies to use, and those choices may change in the future, but you'll see why. So we chose to use Bower, which is a third-party dependency management for front-end resources. So it's like Maven for Java, but it's actually getting resources like jQuery or I don't know, Leaflet or Google Maps libraries. So it's getting JavaScript libraries and fetching them as dependencies, because that's what they are. And we are also using curl and cran, which are tools in the Kojo.js umbrella project. And those tools are basically taking care of the modularization of your application, loading those modules, and bundling those modules and concatenating those into a single file and single output. And we also chose to use Gulp as a build tool chain on the client side, which would be also kind of the equivalent of the build chain for Maven or Gradle. So we decided to take all of those, and we thought that we wanted to have that seamlessly integrated with Gradle, because that's the build tool we're using for Sagan. So we wanted to bridge that gap and have everything integrated between that client side, those tools we used and chose, and the Gradle side that we used to launch the project. So that was the first step. So after that first step, we have everything in the Sagan client module. We have our web app on the other side, and we want to have something that's really nice for us to maintain and use. So we're not using any longer the SRC main web app folder. It's empty. but we kind of need to still ship the application and have something in production. So how do we want to, how should we build that, and how should we ship this application, and at the same time, how should we solve the big problem, which is we want to have the best experience for the best development experience you want to get while developing the website. We don't want to change one JavaScript file and have to, I don't know, relaunch or reload a server or copy files or whatever. We don't want that. We just want to have the best experience. So at first, we want to, that's where we wanted to go, actually. So to solve part of this problem, we chose to use the Spring profiles, which is, you probably know, it's been there for a while now. It's a way of tagging your configuration and activating part of your configuration profiles. So we chose to have some development profile and a production profile. And depending on which profile is activated, then, for example, in development mode, when you're running this Sagan site application, this web app, in development mode, those resources are loaded directly from the disk, but directly from the module, the sagan-client module, which sits beside the Sagan site module. So in development, you have that web application running, and when you're loading resources, you're actually loading from the disk directly from the sagan-client module. So if you're changing a file, then it's right now available, it's updated, you don't have to do anything. So that's the case, that's what we wanted. And so it's not really hard to do because we are actually using the feature Rossen mentioned that's available since 3.0. We are serving just resources from the disk. And that was available, so we did that and it worked perfectly. And so the path, as you can see, that part of the path can be initialized with a property or in many ways. So it really worked nicely and we didn't have much to do on that side. So one first problem solved and that was good. But in production, you want to serve those resources still from the class path with the same mechanism. And those resources, they are not the sources you have in sagan-client, but because they're the actual output of your build, because they're concatenated, minified. It doesn't look at all like the sources you have. So we want to ship those with the application. We want to serve those in production. And at the same time, we want to have also some byproduct of the build shipped with that. Because for example, when you're in production with JavaScript that's been minified during your build, and if you try to debug that JavaScript, you can't read it. It's minified, all the variable names are just changed, it's unreadable. So if you want to do that, you usually have to use source maps, which is some kind of metadata that the browser, many browsers like Chrome or Firefox know how to deal with, and they load that metadata as well. And it enables the browser to just show you the code like it was in the development phase. So nice variable names, pretty output, and you can then put your breakpoints and debug like you were in development mode. So that's something you really need in production if you don't want to read.
And this wasn't the first solution, right? For a time, Sagan was running with a different kind of temporary solution.
Yeah, exactly. That's because at first we were actually we wanted to serve those from the class path, but there was a missing link because the development mode was working okay, but how do we just ship all those optimized resources with the Sagan site module? So at first, then we chose to, because the application was running in production and that we needed to change things and update the application. Then we chose to just do the ugly thing, which is copy the optimized files and check them with the sources. That's ugly. It's still in the commit history on GitHub. You can see that. We're not proud of it, but that's how we did it. And so we had to copy or rsync from the output of the sagan-client module and then paste those into src main web app. So the src main web app was basically just getting the output of the build, and that was definitely not the way we wanted to work, but that was the first step, and we wanted to solve that problem as well.
I mean, the source main web app is very deeply kind of ingrained assumption in Maven project layout, and that's really all the build tools we use, Gradle and Maven. They basically work with Maven layouts, the IDEs. So it's very difficult to go against that convention. You kind of have to go along with it. And so while initially the focus was on modularizing the client side, introducing dependencies like Bower so that you're not just downloading manually dependencies and like optimization and doing all that. The initial solution was to copy the files from the client to the server project on the source main web app, which obviously means that in order to run now, even in development, you have to run this and it copies the files, and then you're okay to start checking your changes. Clearly, that's not a way to develop. That's a step back. But as you can see, a very nice solution emerged, which is actually really simple. So it's almost not fair to see this solution and say, oh yeah, of course. But the process of getting there was also important, and we think that this is, this is a very, very nice solution, which basically means that you can have your client project as a separate module, if you wish to, right? And not have really any downsides. You're practically working as if they were in source main web app, but in production you're working with optimized resources. And as you can see, this approach is also fitting very well with build time, the build time approach to optimizing resources. Because in development, we're just hitting the files where they are on disk, while in production, we're just using the minified and concatenated files because we take the client module, create a jar out of it. That's available now to run. And we can serve it from the class path, so we don't need to be on the source main web app. So it's all working out pretty nicely. There's basically no drawback in terms of the smooth development experience.
Yeah. And even recently, when we took a step back and thought about all that thought process, we thought, yeah, why in the first place we tried to fit everything in SRC main web app? Because if you're trying to do the right thing on the client side, then you have all those build metadata, those tests, those libraries, everything. And why would you try to nest a full module with its own build system, etc., into another module that has nothing to do with it? So, and why should you ship those tests and metadata build system, etc., with your main web application? Well, it doesn't make any sense. So in Java, when we are trying to modularize our application, we create separate modules, separate tests, etc. We don't ship our tests and uncompiled things within our jars. It doesn't make any sense.
Yeah, Bower and NPM download a lot of files, and if you embrace that approach, which coming from Java and working with Maven, it kind of makes complete sense to manage your dependencies like that. Then you probably don't want those under your main Java project. That's not really very nice. But if you put that in a separate client module, it becomes a lot easier to kind of deal with this extra dimensions to having a client side. And that's really what it takes when you start moving towards a modern client and using things the way that JavaScript developers do, because their assumption is that their module is their project, right? And that's really what we're trying to do here. And then once you see the client module in Sagan, you see that all those various aspects of a modern client, it kind of is a lot easier to deal with when it's in a separate project.
Yeah, exactly. So now we had to deal with the problem, which is how to ship those optimized resources with the Sagan site web app. To do that, we thought if we're not putting those resources on the class path in SRC main web app, then we can add those in the class path within the jar. And so that technique can be, some people refer to that technique as web jars, but we'll talk a little bit about it just later. But it's basically static resources bundled into a jar. And that's what we use for Sagan. So the client module is doing its thing, just building, optimizing everything, and putting the output of the build somewhere. And then we are taking that output of the build and bundling that into a jar, and we add that jar as a regular compiled dependency for our Sagan site module, the main web app. So if you follow the whole path, then you can see that in the sagan-client module, we manage our dependencies with npm and bower. We fetch our libraries, we get all that we need. We use our build tools to get those dependencies, get our sources, and optimize them, and do the whole thing like compiling like you do for Java. And once we are done, we're bundling all that into a jar and adding that jar to the class path. And the good thing is, since we were using Spring Boot for Sagan, Spring Boot has those nice defaults where they directly, automatically register resource handling for the class path. So if you have a jar in your class path in a web app, in a boot web app, and if in that jar you have a static directory at the root, and you have resources in there, those resources are served automatically. So it's done for /static, /public, and /web jars, actually. So what are web jars? So another way of doing that, in Sagan we have that separate module, that build, etc., and the jar. Another way of doing this for another kind of application would be to use the webjars.org, which is a separate project. And the main goal of that project is to, instead of getting JavaScript libraries from the web and copying and pasting them into SRC main web app like you do and maintaining those manually, then you can add the dependencies to your Maven regular, Maven POM XML, and then you get dependencies which are jars, and those jars actually contain resources, and those resources are on your class path when you run the application with a specific conventions. It's like /webjars, I think. So boot also serves that directory by default. So if you have webjars on your class path in your application, those resources are available to you into your application. So that's another way of doing this. But that way, if you do that, then you fetch your dependencies from Maven, those static dependencies, but then you have to ship your application in SRC main web app, because that's the way to go. Those two approaches, they're mutually exclusive. You can go with a full client-side module and that deals with its build, its dependencies, tests, etc., and one output, and the main web app doesn't really know what happened and actually doesn't care. It just serves static resources from the class path. But the other way is you still take the conventional approach, but then you have to deal with other issues like having things into SRC main web app. So those two approaches are possible, but we definitely chose the first one for Sagan because we thought that was really the way to go if we wanted to have the best tools and the best experience for our development. So that's what we did, actually. So a short summary of what we've seen with Sagan to tell you that that approach is really has been really tested because we've been using that for several months now in production. So Sagan is a production application. It's been running for more than a year in production on Cloud Foundry. So like in the last 3 months, we deployed that application more than 100 times in continuous deployment. So we're really serious about that one. And we are using that technique in production right now. And we have some feedback, we had some issues, but we know that it works. It's also an open source project, so you can check that out and see how a real application using that technique works. And that's a really compelling argument when you see how things go. And if you want to get more information about the Sagan project and the Spring.io website, I gave a talk yesterday called InsideSpring.io Production Spring Reference Application. You'll probably get an email today, and you'll be able to see the video online if you want to get more. Okay, so Sagan is a quite complete and complex application. It's running in production. We have specific features and all that. So we thought that for this talk, we thought you'd probably needed to have some simple yet powerful examples to show how things go. So we created a separate application. It's called Spring Resource Handling, and it's available in the Spring12jx org. And we are going to see how it works with a demo.
Yeah, kind of the idea behind this is that while Sagan is a complete example, it's also a production application. So if you are, like Dave Sire, a little bit intimidated by using NPM and Node and build tasks, then, and I think that's quite common actually among us Java developers, because this is not what we do most often. What we thought is that we can take our experience from Sagan and create a sample that is about as simple as it gets in order to almost create like a recipe or something that you can take, and even if you don't understand everything, you can kind of repeat it initially and then work your way from there. I think the advantage is that once you begin to put your mind around it, making changes is quite easy, because you go and see, oh, how do JavaScript developers work with Sass? And you take a look and you add three lines to your configuration and you're ready to go. So that's kind of the advantage once you establish that foundation. So the goal here was basically to create something really simple for to demo for this presentation.
So here we took we're going to go over all the basic concepts we talked about and see that in a real but small application to see how things are organized. So here is our resource handling application.
Make that a little bigger.
Yeah, a little bit bigger. Better? Yeah?
If you can't see in the back, raise your hand.
Okay.
A little bigger.
Better. Okay, so here we're going to read to see a couple of files and see how things are organized, and we'll have another demo with real live examples to see how things are working. But here you have a regular Gradle application with a build.gradle file that actually does say, I'm just Gradle, and that's it. So we have, like we mentioned, we have a client module and we have a server module. So if you take a look at the client module, so this client module is totally independent from the server module, like we said earlier. So if you take a look at that one, you'll see that we have a package.json, which is the file, the metadata that's being read by npm to bootstrap the build. So in that package.json, we declare development dependencies. So those are the tools that we will use to build our application. So we'll get Bower, which is the tool we'll use to get front-end dependencies, and we'll use Gulp, which is the tool we use to actually build the application and build our own tool chain. So those are the development dependencies we use, and then we declare a couple of things like scripts, which are kind of Gradle tasks or Maven goals, if you want. So once we have that one, if we install those dependencies with npm install, we get a lot of things. And then if you take a look at Bower, that's where we declare the dependencies our client application needs. So that's where that would be the equivalent of your Maven dependencies for your application. So here we declare that we need jQuery, Bootstrap, less, curl, etc. And we're also declaring overrides, but it's not really relevant here. So we are just declaring dependencies, their names, and their version, and that's it. And then we have the gulp file.js, which will be the build side of things for Maven. So here we have a build tool, and we actually get plugins for that build tool. We declare some variables and some stuff how we organize our project.
Can you make it one more bigger?
One more?
Yeah.
Yeah. And then here we have some tasks, and we'll probably talk about that later. But you just need, for now, to know that we have some tasks, and those tasks are organized just like Maven goals. They're organized in order, and that's all the steps you need to do to have your output for your build. So you have your tasks, and that's it. And so the secret sauce, how we run all this. So since it's a Gradle module, we also have a Gradle module, a build.gradle file. And so we have actually two tasks. One is npm install, and it actually only does it's only doing npm install on the command line. So it's using the native tools behind the curtains to yeah.
Question is it similar to grunt?
Yeah.
Right.
So grunt would be the equivalent of gulp. So that's how you're building your tool chain and all the steps that are necessary to build your build output. So yeah, grunt and gulp are quite somewhat similar. So here we are running npm install to install all the dependencies declared in package.json, and we added some nice things with Gradle to inputs and outputs, which enables us to just run the task only when it's necessary. So if we don't change dependencies in our metadata, like a new dependency or a version, if it didn't change, we are not rerunning the whole thing. Doesn't make sense. So it's if it's up to date, we don't do anything. And then we have another task, which is build, and it's actually running another command on a command line, which is npm run build, and this one is actually running the gulp build. So taking the gulp file.js, parsing that, and running all the steps for your build, and creating the output of your build into this output. And same thing, we are taking the inputs and outputs just to make sure that if nothing changed, so if your sources didn't change, and if you didn't change your main build file, which is gulp file, then we are not going to rerun the same build. So it's up to date, we don't do anything with Gradle. And once it's done, we will jar the whole thing. And so we are taking all the output which has been dist, and we will pack those into a jar, into a static directory. And for that, since when the jar will be on the class path in the second side application, it will be served from the class path. Yeah.
Is this declared as a Java project for Maven just because you wanted that jar path?
Yeah. Exactly. So the question was, are you declaring that project as a Java project just because you wanted the jar task, which is yes. So there are probably many other ways to do that, but that's quite the simplest one we saw until now. But there are probably better ways to organize that. And right now it's not there, but we plan on adding the Maven equivalent to do the exact same thing. And it should be definitely possible. There's no reason not to do that. So I think we're done with the first part of the demo. So this is just a recap. So we saw that Bower downloads the front-end dependencies like jQuery, curl, and Bootstrap, and all that. We saw that gulp is applying the steps to get your sources plus the dependencies and building the actual output of your application. So it's doing things like optimizing JS, minifying CSS files, and all that. And we are copying all the output to a dist directory, would be a target directory in Maven, for example, and we are bundling all that into a jar and serving that from the static, from the class path in production. So why did we did this, and what kind of advantages we got from doing this? So the JavaScript ecosystem is vibrant. It's all over the place. New projects are created every day, and you probably know that. So it's a very rich ecosystem, and we didn't want to be stuck with choices because those choices only exist with the build tools we are using or the technologies we are using. We wanted to have the best one out there. So if you want to do that, then you have to go native and use JavaScript as a native language in your module. So it gives you even the opportunity to make your application evolve, because there's because the client module and the server module are decoupled. Then you have the choice to actually move things and change if you want to, like we did. For example, in Sagan, at first we chose Grunt for the build tool, and then I thought that it didn't look nice, and it was probably just personal preference. But I wanted to use something else, and I tried Gulp. I liked it, and I just changed. And on the server side, we didn't see anything, totally transparent. So I was quite happy we did that, because otherwise I would have to maybe write another Gradle or Maven plugin to call gulp and all that, that would be really painful. So independent works well. And that way you can keep your application aligned with the current front-end trends, and we all know that they change a lot. So that way you can be agile and move things around if you want to. And that was another compelling argument for that approach in SpringMVC, because with SpringMVC we are not only targeting JavaScript application, SPAs and all that, we are also targeting all the client languages that exist out there. So if you're developing a JavaScript application or a Dart client application, or even JavaScript, the next version of JavaScript, which is ES6, or TypeScript or CoffeeScript or whatever, that approach should work. And we're quite happy it does, because we want to be able to help you develop those applications with SpringMVC. To you now.
Yeah, how are we doing on time?
Oh, is that me?
How are we doing on time, actually?
Oh.
Yes, and one more thing to add to the last slide is that with HTTP 2 on the horizon, that adds another dimension to this whole discussion, because all the things that we do to optimize resources and concatenate them, that's kind of the area that HTTP 2 is targeting as well, trying to make that more optimal. There's a lot to be said about the fact that this concatenation sometimes works against actually being optimal, because once you concatenate, you're now downloading the same big thing on every page, and that's not exactly very optimal. So there's things for that in HTTP 2 that may completely change the way we think about these optimizations in the not so distant future. So that's yet another reason why we like this approach, because it's flexible to any backend, it's flexible to any front end. There's a lot of choice there, and it's also with HTTP 2 that's also something that's going to change things quite a bit. Now, if we are using Java build tasks on the client side, then the question is, what can SpringMVC do? Or what can the server side do? What is naturally suited for the server side? Well, for once, we can make it easy to work in different environments, switch between development and production, and be able to work with unoptimized sources. Just having a comprehensive strategy, make sure that that thing works, is really what we wanted to make sure. Pluggable resolution of resources. We want to make sure that wherever they may be, optimized, transpiled, gzip, we can find them and serve them. So not just any location, but also different strategies about how to resolve URLs, etc. We may need to even insert or modify URLs in order to apply some of these strategies. Versioning in particular is one we'll be talking about shortly. Producing HTML5 app cache manifests or helping to serve them, prepare links with CDN domains. So there's still plenty of things that we can do to make sure that works well with the server side. And this is where we talk about what's in Spring Framework 4.1. Well, taking our existing resource HTTP request handler, we essentially add two new strategies there. One is the resource resolver, and the other one is the resource transformer. And these are used to form two chains, the resolver chain and the transformer chain. And basically what that means is that we're no longer simply resolving resources based on the path relative to one or more locations. We're now able to have different strategies for how to take a URL and match it to some file somewhere. And that could be resolving a version in the URL. That could be dealing with .less extension, looking at gzip encoding in the accept header, a variety of things that can be put into strategies. So basically, arbitrary resolution of resources that goes beyond just resolving a path to a file. And then the other aspect of that is being able to determine the public URL that needs to be served. For that, we have a resource URL provider. And we'll see that shortly. We'll see more about that shortly. So what kind of built-in resolvers do we have? So we have the path resource resolver. effectively that does what the resource HTTP request handler has been doing for some time. It takes the path of the URL and tries to find a file relative to the configured locations. So if it's /foo.css, it basically says, all right, where are the files on the /static? Fine. Let me see if I have something under there called foo.css. Just a simple lookup. Then we have the version resource resolver, and that's really kind of the most important feature here in the server side that is now built into the framework. It's not just suggestions for how it can be done. There's a gzip resource resolver, which looks at the accept header, and if it's gzip and we can't find a file that matches, let's say you're looking for /foo.css again, and there's no such file. Well, we're going to take a look at foo.css.gz as well. Is there such a file? And if we find it, then we can serve it. So that's an example of a resource resolver strategy. And then in addition to that, we also have a caching resolver, because some of these can be computationally intensive. Computing the version of a file from its content, well, that's definitely not something that you want to repeat every time you're rendering a link. So we want to make sure that we cache the results. And this caching resolver is using Spring's cache abstraction internally, so that works pretty nicely. Then we have a few built-in transformers. In particular, we have one for taking a CSS file and updating the links that are inside it. So now if we're transforming links, putting a version in them, we also have to do that inside other resources. Same thing we do for an app cache HTML5 manifest. Also inserting a comment inside which will invalidate the cache file itself. And of course, caching the transformer, same idea. Okay, resource URLs. I mentioned already that we need to be able to modify them. So it's no longer just a simple path that we just try to find a match for. Now these strategies, having a strategy for resolving resources means that we have a more sophisticated algorithm, which also means that we have to have more sophisticated URLs that contain some information in them. So basically, if you look at the resource resolver contract, it can actually do two things. It can resolve a resource given the incoming URL. It can say, all right, what's this URL? Let me try to find a matching file, a matching resource. And then the other side of that equation is, I want to prepare a link. I want to render a link to this resource. What's the public URL? So, for example, I may choose to insert a version in the URL. And then we have a resource URL provider. Typically, you wouldn't go to the resolver directly. There's a resource URL provider, which is a central component which on startup detects all the resource handler mappings and is kind of aware of them. So when you're rendering a link, you can ask it, give me the public URL for this /foo.css. And it goes through all the mappings and it tries to find a match, and it says, all right, this one is actually a mapped resource. Let me prepare the public URL for that, and maybe inserts a version. But if the URL doesn't happen to be matching to any kind of resource, which the resolver should know, we get a null back, which means that, okay, this is not a resource URL. There's no need to modify it in any way. So these are kind of foundational mechanisms that we need in order to have an arbitrary resolution of resources. So now, how do we actually render links in our views, whether it's JSP, whether it's some other view technology? We have just about the simplest way to do that is to plug in a filter that we provide and called the resource URL encoding filter. And what that filter does is it wraps the servlet response and overrides the encode URL method, so that every time URL gets encoded, it will actually check to see if it is a resource URL and rewrite it. And why this works is, if you're not familiar, the purpose of this encode URL method in the servlet response is, for example, to insert the JSession ID into the URL. If, let's say cookies are disabled, then that needs to be inserted into the URL. And that's really what this encode URL is used for typically. So it actually is invoked, for example, from JSPs. If you're using the URL tag or from JSTL tag library or from the Spring library, then that's automatically done, which means that simply plugging in the filter just basically works. And the same is true for free marker and velocity, because the macros that we provide actually do the same. They give you a link, a macro for creating a relative URL. Or if your view technology that you're using is not using the servlet response encode URL, then it's also, let's say, using something like handlebars, and we have an example of that in the sample. Then you basically have to get access to the resource URL provider, which is a singleton in your Spring configuration, comes with the MVC Java config. And when you get access to that, you need basically to use it to rewrite the links. And typically the view technology like handlebars or for Groovy, also we have integration there. They give you some way to create a helper, and then you can use that helper, which is like a JSTL tag, essentially, in JSPs. And you can use that in your views in order to render links to CSS files, to JavaScript files, to make sure that they get rendered as necessary. And we're going to see that in action shortly. What about links inside other resources? If you have import statements inside CSS files, we have a couple of transformers to help with that. And in fact, if you configure versioning with our MVC Java config or XML config, we're going to help do that automatically. So we kind of know that it needs to be done. The version resource resolver, basically, we started with the notion of fingerprinting URLs, which comes from Ruby on Rails. But eventually we arrived at something a little bit more general called a version resource resolver, which contains a content version strategy. That basically is what gives you fingerprinting URLs. And there's also a fixed version strategy, which inserts a prefix at the beginning of the URL. And that's a fixed prefix that could be anything. It could be a version that comes from a property file. It could be the current date, or maybe even a GitHub commit SHA, which is what's used in Sagan. So when to use which version strategy? The content version strategy is a good starting point. It's basically an automated version. It's computed for you. You don't have to think of what the version should be. It's also very efficient in terms of caching, because as soon as the file changes, only that file gets reloaded in the browser. All right, that's kind of the idea of fingerprinting URLs. Then the question is, why not always use the content version strategy, since it is really the best choice? Well, if you're using JavaScript module loaders on the client side, then it really doesn't work well with the fingerprinting URLs, because the JavaScript module loaders, which is, by the way, a good practice on the client side, and that's certainly what Sagan does. Basically, the run.js file has links to all the Java components, or rather, it has the names of those JavaScript components, has to know where they live, and it may optimize them at build time. And then when you say require, or when you're actually pulling in one of these JavaScript modules, it may or may not go to the server. It may have already downloaded it. That's really what a JavaScript module loader does. It's much smarter than just a simple link to a JavaScript file, which basically means that using fingerprinting URLs kind of gets in the way of all that. And this is again where aligning with the build tasks, JavaScript build tasks, allows us to build a comprehensive strategy with these kinds of details in mind, so that you can be prepared and be able to work with that. So where do we actually draw the line? I mean, you can kind of tell from everything we've said so far which way we lean and what we prefer. This is, of course, by no means the only possible choice, but our first and foremost goal was to enable flexible resource resolution. In other words, let's build a foundation which remains agnostic to whatever approach is taken. From there, we basically decided that we're going to focus on relying on JavaScript build tasks to achieve a lot of the optimization and transpilation. And that runtime transformations are really, we're going to limit ourselves to doing any kind of runtime transformation only where we absolutely need it. So for example, if we talk about versioning of URLs, which is absolutely a feature for the server side, then we have to be able to transform CSS files in order to insert versions into their links. So that's an example of where we have to do transformation. But we're not going to build transformers for doing concatenation or minification. That's really where we've decided to draw the line with what we provide. And we think it works well in Sagan. We realize that that's not an approach that everybody is going to fit everybody, but basically that's where we chose to position ourselves. And we provide what we need on the server side, like for example URL versioning, and make sure that it works well with JavaScript build plugins. Now, can a full asset pipeline still be supported? Yes, actually the foundation, as I said, is very flexible. And very fortunately, right before the GA release, we have here a link to a third-party library, which seems to have pretty extensive kind of optimization capabilities that was looking for a way to integrate with Spring. And the new version of SpringMVC 4.1 actually turned out to be sort of green light. All right, here's the solution. If you look at the actual integration that's in the framework now, it's basically 3 classes that are pretty straightforward. They just implement a resource resolver transformer, and I think they do something in the resource URL provider. It is possible to take Java build tools or runtime tools for optimization and build them on top of this foundation. Right. How much time do we have?
Yeah, are we on time? Okay.
Oh, we have time.
Yeah,
all right. Yeah, so we're going to take a look actually now at some code. We're going to do a demo. Brian is going to do a demo.
Yeah, so we are going to take a look at how we configure things on the server side, and we're going to translate everything Rossen talked about into a simple configuration that is really easy to read. So if you take a look at our simple boot application, we have an application.java which just bootstraps the boot application, and we've separated the config into another file just to make things clear. And so we have this configuration, this web config, which with enable web MVC, etc. And here we are configuring we are configuring several things actually. We are configuring view controllers. We are just setting mapping URLs to view names for the purpose of that application. And we are creating several things like handlebars view resolver, because we want to try things with handlebars views. So we created one handlebars view resolver, and we integrated that library handlebars Java into our app. We also wanted to try things with the groovy new templating engine. So we added another resolver and a configurer with all that. And we also wanted to deal with the JSPs with our example, so we added another one. And we created the resource URL encoding filter to actually rewrite the URLs within JSPs. Like Rossen mentioned earlier, so this filter will deal with JSPs, velocity, free marker, and for the other views we are actually doing something else. Here, for example, we are registering a helper that we will use to write those URLs into our templates, those nice URLs. So that's a helper, and we'll see that it's really easy to implement. And the support should be easy to add into many templating engines, actually. So here's the core of the configuration for our project. So here we are just checking in which profile, if we are in development mode or not. So we are checking that as well. If we are in development mode, then we want to read files directly from the disk. If we're not in dev mode, we want to get those from the class path. All right. Then if we are in dev mode, then we want to have a cache period to 0, which means we don't want our browser to aggressively cache those resources. So we want to make sure that the server tells the client to not cache the resources. And then we are getting the version string we want to use to version our JavaScript resources. And then that's
because
when
we use a module script,
exactly.
module loader. So we're going to use the prefix version, as you'll see here from the fixed strategy configuration.
Yeah, exactly. And so here we have also another thing into our application. We wanted to try things with an app cache manifest. So if you're not aware of that, that's an HTML5 feature. If you are building a client-side application that relies that can have an offline mode, you want to declare to have a manifest served by the server, and that manifest basically tells the browser which resources should be downloaded, cached, etc. That way, when your application goes offline, you can still browse your application and use that application. So that's one HTML5 feature, really interesting. If you're building a real single-page app, independent app, that can have offline capabilities, then you should definitely use that. So here, that's the bulk of the configuration. We create a version resource resolver, and like Rossen mentioned, we want to have several strategies. One strategy with a fixed version for the JavaScript modules. So we prepend a fixed version string into all the URLs for JavaScript resources. And for all the other resources, CSS files, images, etc., they don't need that kind of strategy. A regular content version strategy with the fingerprints into the file name just works better. So that's what we are using.
And from this configuration, you see we're adding one version resolver and one transformer. But actually, because of the use resource cache boolean, that means that we're going to insert a caching resolver at number 1, and also a caching transformer in the beginning. And because we're using a version resource resolver, we're going to automatically add a CSS link transformer as well. So there's a bit more to this, to the full resource chain. Oh, and there's a path resource resolver at the end, but that always has to be there, right? At the end, we always have to find where the file is. But you can see the configuration is rather minimum. You just focus on what you need. But if you actually add your own path resolver, we just back off and, okay, we take the one you provide. Question?
On the version resource resolver strategies, does the first match win? Is that how it works?
So the question is on the version resolver, does the first match win? Yeah, basically that's how it is, right?
Yeah, totally.
Right.
So you need to be consistent. But I'm wondering if we don't even just sort those as well ourselves.
It's a good question, yeah.
Well, we may sort those if you didn't use the right order. We may sort those using the pattern you used.
The main use case so far has been, just a very simple switch between JS files and or just fall back on a default version. Hopefully it works, but if not, we're right now in 4.1.1 mode. It's always like you hit GA and then, oh wait, somebody's actually using it, and then we end up having a lot of fixes in 4.1.1. So,
but we worked a lot on all the logging side of things. So if you turn on logging for that particular package, you get a really interesting logging, and you know how things happen. So you really know.
Yeah, it isn't meant to be quite as sophisticated as, I guess, if you're comparing to simple URL handler mappings. But I can imagine that in a real project, sometimes you may have something that requires much more nuanced mappings.
Yeah. So here, the last part, we just tie all the things together. We are creating a regular resource handler for all the resources. We are telling him to get those resources from the location, which would be the disk or the class path, depending on the profile. We are setting the cache period, so 0 or nothing, depending on if you're in development mode or not. And then we are creating the resource chain, which is the new part of the API here. and we're telling him to use the resource cache or not. So if you're in development mode, you don't care if you're redoing the same thing, if it's CPU intensive. You just want to have the latest version, and you just want your modifications to be taken into account right away. So in production, you want to enable that because you don't want to waste CPU cycles doing the same thing over and over again. But in development mode, that would be a good thing to disable that one.
See it in action.
So let's see that in action. All right, so here we're going to launch the application with the development profile.
Can you make that a little bigger? There. So this is just Gradle build running, and boot starts up.
Okay, so in our application development mode, so the really simple web app, you probably saw a little flicker. It's just that the hello world is actually a JavaScript template. So we are writing the JavaScript template, so we're sure that it's a JavaScript enabled application. So here, if we take a look at the actual source code of the page, bigger. So here, a really simple page, and you can actually see that we have those strategies running in development mode. So we've got the version strategy kicking in for the main CSS file with the fingerprint being written in the file name. So whenever you change the file, the fingerprint will change. Same thing for the JavaScript files. So in development mode, I chose to use, for example, this dev string. Because in development mode, what you do is often you're putting breakpoints into your JavaScript file. So you don't want to change that prefix, otherwise your browser would be lost every time you change the file. That's counterproductive. So you want that prefix to stay the same while you're developing. In production, you can do whatever you need to do, like use the date or commit SHA, whatever. That's how you go there. And you can see that the title, Hello Spring, is actually a template. So we did do the right thing in JavaScript. And if you take a look at that main.css file, so that's the actual CSS file you get on disk in development mode. You can see that it also rewrote the right parts in the CSS file with the strategy we set up at first. So the other libraries, the other CSS files we have import. So if it's an external one, it doesn't do anything. You don't want to rewrite those, then it doesn't do.
And basically that calculation happens once, and it should be now cached by the caching resource resolver, which, as I said, is actually a cache, uses Spring's cache abstraction, and by default, it's just a concurrent map backing it. So it's quite simple, which should work actually for most cases. But you can actually configure the cache. You can plug in ehcache or any of the other strategies. Yeah. And because it is a bean in the Spring context, the cache, you can clear it. You can, for example, easily write yourself or go into JMX console and clear the cache. So basically, you run the application, the cache gets built, everybody is just serving from cached resources. There's no more calculating of these links. But if you actually want to blow the cache, it's quite easy. Just clear the cache and let it rebuild once again, which you'll take a little bit of a hit, but from thereafter, it should work fine.
Since we're in development mode, then we can change our file, in our CSS file, and go back here. And if you take a look, we reload. Okay, it still works. And here we should see the SHA change.
Did you remember the last number?
AC6 was ending with AC6. So okay, it did change. It loaded the file from disk and updated the fingerprint for that one. Are we good on time? Still got 10 minutes. Should we? Okay, just we can maybe go to Q&A and just show a couple of other endpoints. If you have questions about those technologies, we can answer them right away. So here it is an example with handlebars. So we can talk about that. But the thing is, okay, handlebars. So our main index page was this. So we registered a helper with handlebars that we called SRC, and so that way we can ask to could you write the public URL for this resource, and it will be done at runtime, and but cached if you do the right thing with your templating engine. Same thing with your JavaScript resources. We have those helpers to help us create those links. But we have also a less example. So if we go there, we're in dev mode, so we want to use we're using less as a style sheet language. So if we take a look at the style sheet, it's like this. So it's got some features that CSS, the regular CSS don't have, like variables. So we created a variable called images for a path, and then we use that into URLs here. So this is a regular less file. So in development mode, we chose to use directly less. And we even dynamically added the less transpiler, which there is a JavaScript version for a transpiler. So you could definitely have a whole tool chain and run that as part of your application. But there's one, a JavaScript one. So the only thing I had to do is just add that script tag, and that's it. So less support in development mode.
Yeah, so basically the advantage again of the JavaScript build tools is that if you see something anywhere, as an example of, let's say, less or whatever it may be, well, if you wonder, so how do I do this in my application? So the line of thinking there is, well, how would a JavaScript developer do this? And you look it up, and there's a wide body of knowledge. So that's kind of the advantage of the big ecosystem that's behind. You can bet basically that there's a way to do it because that's somebody would have thought about it already.
So same thing with the no development. So just we're not just
not show how it's done in the source.
Yeah. So in the source, the less one. So same thing, and I even created another helper with my templating engine, saying if we're in development profile, then use the less file directly and use the as well the less transpiler. But if we're not, then use just the style.css file, which will be built by the JavaScript build tool chain. So that's.
So there's basically a way to do it, by managing that in the HTML file. And I can point out here that we could, for example, build a less transformer. We have the resource transformer. We could provide transpilation of less into CSS. That's something the foundation can do. We haven't done it yet. But we could do it, and that's something that would be there to make the development experience easier so that you don't have to manage in the source if-else conditions when you're pasting a CSS.
Yeah.
But again, our approach and strategies, we're not really advocating doing this in production. We may use transformation to simplify the development experience, like a runtime transpilation or transformation, but ultimately, this isn't so bad, basically, if you have a way to work with less. And
and really, that's the most simple approach we could do. If you're working with a templating engine, I'm sure the maintainer of those engines can do many other things that looks more natural in those templating engines. So here in production, for example, we have the transpiled version. We use the transpiled version. If you take a look at the source, we're using directly the CSS. And that's the one that was built by the JavaScript build tool chain. So all the imports were concatenated and everything minified, so you got a production-ready file for your application.
Let's open for questions.
Yeah. So if you've got questions, if you want to see some other examples we mentioned, then just go ahead.
Any questions? Yes.
How easy it is to run this rank of broadcast from Maven?
The which? To run what?
Uh-huh.
Yeah.
Obviously, you showed running them from Gradle.
Right.
Is it easy to run them from Maven as well?
Okay, so the question is how easy it is to integrate Grunt or Gulp with Maven.
Okay, so yeah, basically we did it with the Gradle we showed you. It's just a matter of launching an external command line, and Maven has that capability as well. So you can just go Maven exec and launch the external tools as well. And we'll add that to the examples to show you how it can be done. But yeah, basically that can be done.
Yeah. Yes.
Do you have an example of including those process URLs in Timeleaf?
In Timeleaf?
An example of doing the same in Timeleaf.
I don't think we have that one right now, but it's totally...
There's a good chance it's using the servlet response in code URL, so it might just work with the filter.
Yeah.
Yeah.
So,
But you know, the Timeleaf guys, if not, the Timeleaf guys follow up pretty quickly. So in fact, meant to get in touch with them, but
yeah.
Yeah, we'll follow up.
If you use the at, if you use the at in your expression,
Yeah.
Okay.
it will do the encoding.
Okay.
There you go. All right, so we have an answer.
So if you
use the
at
at to cause the encoding.
Same thing with like if you're on a different context. If you use the at, it'll like the context prefix servlet context as well as.
Okay. Yeah.
Yeah.
All right. Thanks.
Thanks.
Any other questions? All right. Oh, one more.
Separate, but Hope does look better than Grunt. Is it hooked in with the Grunt modules? Like, can you use the same modules or is it all separate?
Oh, so the question is, are Gulp and Grunt totally separate tools, and are the communities totally separate? So in a way, yes, because you won't use a Grunt plugin within Gulp and vice versa. But at the same time, those plugins, they're quite light, and they often use the same libraries behind the curtains. So for example, if you're minifying JavaScript resources, they're all using basically the Uglify library or Clozel compiler, all of those. So here we're using a Gulp plugin that uses the Uglify library. So the Gulp plugin is really light. I wrote myself a couple of those, and it's really they're usually just one file and not much to write. So the Gulp ecosystem and Grunt ecosystem are really similar in that sense. They have many features.
All right. Thank you very much for coming, and enjoy the rest of the conference.
Thanks.